Hello everyone. Today I am start with the basic of calculus. Okay. First I defining some basic definition and then we can understand the what is the meaning of that definition. Okay. Let's start. The first definition: neighborhood of a point. Of a point. Okay. So first I write the mathematical definition, then I can explain and open. Try to understand. I think you know what is the open interval. Okay, first I write the mathematical definition. An open interval a minus delta a plus delta. Okay, this is an open interval where what is the delta? Delta is a positive real number. Clear? Then it is called the neighborhood of a point a. Okay, and how to define this neighborhood? That means in real life, just take this real line. A is here, and what is delta is called? Delta is called radius. What where a plus delta should be there? In right side a plus delta, and left side a minus delta. Okay, then this open interval is called the neighborhood of this point. Clear? Now take an example. Okay, I take 2 comma 4 as an open interval. Assume 2 is here and 4 is here. Can I say that this is the neighborhood of 3? Because 4 I can write 3 plus 1. Okay, 2 I can write 3 minus 1. This is look like na same. A plus delta, 3 plus delta, 3 plus 1, 3 minus 1. Okay, then I can say that 3 is the 3 is in 2 comma 4. That means this interval is the neighborhood of 3. Clear? Maybe definition clear? Okay. Now someone thinking that always a neighborhood should be open interval. This is not true, because what is the general definitions for neighborhood of a point? Try to understand. Let us assume I am defining another definition. Let us assume n is a set. Okay, and take one open interval u which is belong to n. Clear? Now I took one point A from U. Okay, sorry, this is not belongs to, this should be subset because of U is a open set. A belongs to U. Then we can say that U, sorry, A belongs to U and subset of N. I can write this implies. Clear now? Then I can say that N is the neighborhood of, this is the short form of neighborhood of A. Definition may be clear, just try to understand. Okay, first I give you one example. Okay, just don't worry. Example, take, I took one set like closed interval 5 comma 8 n equal to. Clear? Now I want to show that this n is the neighborhood of 6. How to show? Clear? In the using these definitions only, this. Okay, how to show? I want to show, take a equal to 6. Okay, now the according to our definition I have to find an open interval. value, take 5 comma 7. Can I say that this is an open interval for 6? Because if I write 5 here, 7 here, can I 6? This is an open interval. Clear? Maybe this U is clear. Then observe here, A belongs to U. Clear? Obviously. And also we see that this is the subset of 5 comma 8, which is equal to n. That means we can say that using these definitions, we can say that 6 belongs to U means what? 5, sorry, open interval 5 comma 6, and which is subset of close interval 5 comma 8. That is n is the neighborhood of 6. Okay, I think neighborhood definition is clear. Okay, now next definitions, which is deleted neighborhood of a point. What is the meaning of deleted neighborhood of a point? Okay, what is first I defining just nothing but, you know now what is the neighborhood of a point. Clear? Just remove that particular point, then you can get the deleted neighborhood of a point. What is that? Let us assume a comma b is the neighborhood of c. Then what, how I can draw? Here a, here b, sorry, and here c. Okay, I told you that what is the deleted neighbor. A comma b is the neighborhood of c. Then how to find the deleted neighborhood? Just remove c from a comma b. Then this set is called the deleted neighborhood of c. Clear? Okay, take an example. Just give me 2 comma 4 is the NBD of 3 with delta equal to 1, which is greater than 0. Clear? Now what is the deleted neighborhood of 3? I said that just remove 3 from the neighborhood. That means 2 comma 4, just remove 3 here. This is the deleted neighborhood. And also you can write this set as a 2 comma 3 open interval union 3 comma 4 open interval. Clear? Maybe deleted neighborhood is clear. Okay, now the next topic, sorry, next definition is the what is the meaning of extending to a. Okay, then try to understand what is the meaning of extending to a. Just first observe, if I draw a line, a is here, assume extending to may, sorry, extending to a means how to approach, means we can choose either this path to reach a, also we can choose this path to reach a. Okay, that means we can either go in right side of a, also we can reach to a from left side. Clear? So the first is I want to go from left side. That means this denotation is x tending to a negative. That means we are goes from here to here. Okay, clear? This is denotation, and extend that denotation is negative because of left side. Clear? And second, if I write this a positive, that means we are coming from right side. This clear now. Then nothing, this is clear maybe. And remarks, first, what is the equivalent definitions? If x tending to a means what is equal to x equal to a plus minus h, what is the meaning of that? I am trying to say, what is the meaning? Why I write x tending to a is equal to x equal to a plus h, clear? And h tending to 0, why? Because of, assume x equal to a plus h, first take, and h tending to 0 positive. A plus h means what? Because h, I can write a plus h here and a minus h here, clear now? Then a plus h tending to 0. If h going to 0, that means what? This is going to here now, clear? Also from, look here, if h going to 0, then a minus h going to a only. So that statement is same, this and this, clear now? Just again, a plus h, I can write it, since h is positive number, that means a is here, a plus h should be right here, okay, assume, and a minus h should be here, look like in a neighborhood of a point, clear? So if h tending to 0, that means h is closer to 0, that's, this should be going to a now. Just take an example, if this is 5, 5 plus h and 5 minus h, okay, I am taking h closer to 0, first take h is equal to 1, h is equal to 1, then what it should be? 5, 6 and 4, then take h is equal to closer to 0, that means take half, that should be, sorry, 5, just one thing, remove this, 1 minute, okay, 5, 6, 5 plus half, 5 plus half means like here 6, here I can write 5 plus half, here 4, this is 5 minus half, clear na? Whenever you are taking age as much as small na, this is look like going to 5, this is going to 5, clear maybe definition? Okay, now using this meaning of extending to a neighborhood and related neighborhood, using this I can define limit of a function. Limit of a function. Try to understand, this is the important concept. Okay, limit of a function means whenever you are, this is I already told that how to meaning of extending to a, that means how to you reach a, okay, whenever you are going to a, okay now, then where a function is, corresponding function is going, that is the actual motivation. Just try to understand, assuming this is our graph, whatever graph, okay, assume a is here. So I already told you that how to, what is the meaning of extending to a, you can come with this way or come you in this way, okay, then try to understand where function is going, corresponding f of a value, if function is coming also this side and can coming also this side, okay now, then if function is coming a particular value, then we can say that the limit of a function is that particular. value. Just I write the definition, then also I can give you example. Limit of a function at a point x equal to a. Okay, then how to define? First case one, a is a real number. Just 1 minute. Just try to understand the definitions. If x tending to a and the corresponding functional value also tending to a particular real number, try to understand, then L is called limit of f of x at x equal to a point. What is the definition is actually saying? I am draw this graph. Okay, assume x equal to a here. This definition says that if x tending to a, that means you can come with this way or this way. Okay, if the functional value f of x is going to a particular real number also, whenever you are coming with x in left side, also function going in this way now, this way. If you coming from right side, function also coming from right side. Clear now? If they are coming a particular value which is L, okay, this L is called limit of that functions. Clear? Okay, now take a proper example. Assuming that I take function f of x equal to x square. What is the graph for that? Maybe this is sorry, this is the sorry 1 minute. Okay, this is the graph of it. I want to check what is the limit of a of these functions at x equal to 2 point, x equal to 2 maybe here. Okay, now just look here. If you goes from left side, functional also goes from left side. What is the fun left side? Okay, in the right side also the coming right side, this as a limit L should be clear now. Then what is the f of 2 value? 2 square means equal to 4. Clear? Then actually this is the graphical way I can defining the limit. Okay, and maybe this is clear. Now the case 2, limit at infinity. What is the meaning of limit at infinity? Limit at infinity means whenever, first definition says that we are going to particular point x equal to a, but in limit of at infinity, that means whenever you are going to infinity, either this way, this is positive infinity, you can go this way also, this is negative infinity. Whenever x is going to infinity, where function is going, if function is going to a particular real number, then I can say that the functional limit exists at infinity. Okay, I write the definition. Okay, a real number L is said to be limit of a function x. Okay, if x tending to infinity, this should be either positive, negative, both. 1 minute. Plus minus infinity. Then f of x tending to n. Okay, just take an example. If I draw this graph, just try to observe. This is assume this is y equal to 1, and assuming this function goes to closer to 1. Okay, what is the limit for these functions? X tending to infinity. Okay, na? Then where function is going? Function is going like closer to 1. This is 1, closer to 1, not going to 1. Then the limit of these functions is f of x equal to 1 at x equal to plus infinity. Maybe this definition clear. Okay,